Hello, everyone. The Enkido training team would like to extend a warm welcome to you. We are thrilled today to have you join us for our webinar on evaluating downhole performance using production logging tools, PLT. My name is Mohammed, and I will be your host for this session. The webinar will be presented by our speaker, Mr. Mazin Al-Hilali. Mr. Mazin Al-Hilali holds a master's degree in petroleum engineering from the University of Baghdad, uh, 2006, and a bachelor's degree in petroleum engineering from the same university in 2002. Mr. Mazen is currently a senior engineer specializing in petrophysics and reservoir surveillance with a cumulative 20 years of upstream experience in geoscience and field operations. He has developed expertise in wireline cased hole seasonal experience and open hole petrophysical analysis. Additionally, Mr. Mazen is actively involved in volunteering, serving as the chairperson of Spawla Iraq chapter and participating in SPE Spawla activities. Before we begin, please note the following important points. If you have any questions during the presentation, please type them into the question and answer box, and we will address them during the Q&A session at the end. Please be aware that this session is being recorded. Throughout the presentation, we will share links in the chat box that will enable you to connect with Enkido training on LinkedIn, Facebook, WhatsApp, and YouTube. The link for the certificate registration form will be provided at the end of the presentation. Certificates will only be issued based on the information provided through the published link at the end of the webinar. Please join me in welcoming Mr. Mazin Al-Hilali. Mr. Mazin, please feel free to introduce yourself in detail. The floor is yours.
Thank you, Dr. Mohammed. It's my great pleasure to present this webinar in collaboration with Enkido Training. I believe your introduction have been covered most of my study and experience. Not much to add. Most of my experience have been spent in southern Iraq oil field, middle Iraq, and also Kurdistan oil field, focusing on in the recent years on cased hole surveillance and integrity as well. Maybe we make one webinar regarding integrity in the future. Recently, I'm volunteering with the SPWLA Iraq, and I'm encourage you to visit its YouTube channel and to attend our webinar. I will add some link at the end of presentation. It will be related to this webinar. In general, this webinar will be short. It is not like a detailed course about all the tool physics and theory. This will need like a full week or even maybe 2 or 3 weeks to cover all these things. This is like an overview to understand the production logging tool, the conventional and the advanced type that available in the market, okay, with the quick case studies. As Dr. Mohammed have been noted, will be kindly to keep your question in the chat box and we can answer them at the end of this webinar. We'll try to be tight with the time, which is about 60 minutes. We'll talk about what is conventional PLT, what the data required to analyze PLT, how we transport, okay, the PLT string to our downhole target, which we called short-term convey systems, why we run PLT, what is the benefit of PLT, what is the tool of PLT, a quick operation overview, why we need all these PLT string, why we don't use one PLT log and that's all, why we use full string of PLT tool, What is apparent downhole flow or recirculation that's happening in deviated well? Um, what is a crossflow? Horizontal wells overview, very quick. Multi-array production logging tool. Okay, we'll get some quick idea. Also, we'll take a look on the most famous software in the market. So, what is conventional PLT? Dr. Mohammed, hello?
Yes, I hear you.
Can you pause the recording because I will show some
Sure,
confidential video.
sure. Okay.
Okay, so now you see what is PLT string. Okay, so what it's required to analyze this data. Okay, so I make this what is called mind map plot. Okay, to explain what you to be in the domain of the production logging tool analysis. It is a multidisciplinary science that interact with many other domains. Okay, it's you need to have some idea about completion, what data QC, what is PLT tool benefit, PLT tool physics, or the physics itself, reservoir knowledge, flow regimes, this is some kind of related to production engineering, hold up modeling, software proficient, which is very critical part because each software has its own tricks, props and cons, multi-phase flow modeling, PVTs for the fluids, for the water, for the gas, for the oil. Okay, the well bore, which is mean pressure, volume, temperature. Okay, um, and also the operation side of production logging tool. Okay, so this is the many knowledges you need to acquire to understand before go and jump and start analyzing PLT. So you'll have some kind of big picture. So let's go now. How we take all that tool that we saw on the previous slide or video to downhole target. We called it convey system, convey transport system. If you heard the movie Transporter, okay, how we transport it, okay? There is different way. We can use wireline truck, we can use silk line truck, we can use cold tubing, and each one have its up and down, okay? Like for wireline truck, it can be used to the till the and silk line also till the deviation of 60 degree. More than that, you will need a cold tubing unit. Okay, wireline is usually like it can give you what's called surface readout (SRO). You read the data directly on the field. You'll see if there is any problem that you're already reading. Silk line is a very cheap surfaces. Maybe you can use it in an injector well or something like that. You don't see the data. You don't to have a very professional wireline engineer on set, but you will need this wireline engineer later in the lab to extract the data, which is a very tedious operation to get the data from the memory, especially when you have some time tool with hundreds of curve like a fast or a sonar or something. Uh, but it's very good if you go for injector. You don't looking for a very high quality data and your field have 100 or 200 injector well. Okay, especially in very old and big fields. This will be very good deal. Cold tubing. There is two type of cold tubing. It's like what the one which is e-coil, which is very you can see the data as in the wire line. You see directly on the surface readout. And there is the conventional cold tubing, which is you need to connect your production logging tool to a battery and will be read on memory. Okay. So depend on your application, depend on your budget, okay, depend on your well completion and deviation, you will select your convey system. And this is the most common way. Maybe there is a tractor also, okay, to reach this one, but I mostly see it in open hole. Okay. Why we run PLT? Too many benefits. Okay, this is the benefit to identify merely to see the flow from each zone. Sometimes you use it as integrity tool. Sometimes you want to see the injector zone. We call it intake. Sometimes you want to see the thief zone. Sometimes you want to see if there is some kind of cross flow, as we said, thief zone. If some has integrity, like if sparkle leaking, SSD leaking, okay, tubing leaking, okay, and maybe one tool is not enough. You need to connect more extra tool with it, okay. But in general, okay, this is the benefit. So this is a thief zone. Usually in shut-in, you run PLT and you can see there is a zone that have low pressure and taking. And we see this a lot in many fields in where I work, okay, in Iraq and Middle East. Okay, completion problem. Maybe you put some packer here and there is a leak in SSD or there is a hole in tubing. Okay, you can't catch this one with the if it's on dynamic. Okay, this if this well on dynamic, you can see that in using PLT. So it be some kind of integrity tool. I recently delivered some kind of integrity webinar, and I consider PLT one kind of integrity evaluation tool. If there is, I saw such many cases. You put a plug there, and when you go PLT and you see some kind of flow here, flow going there, if it's injector wall. Okay. Cementing issue, you can see that if you have some temperature log. The temperature log is the only log that can see behind the casing. This is like you can see if there is water encroachment from below or if you're injecting gas from above. Okay, actually, frankly speaking, I didn't deal with gas well. Okay, it is not in the field that I dealt during my experience. Okay. So sometime you run PLT in a producer well injector and you perforate 100 meter and boom, you see all this production come from 1 or 2 meter, or you see all the injection going to half meter or uh, 3 meter or something. Okay, there is some kind of fracture. Okay, and usually the difference between fracture and fall, the fracture do not have a clear displacement geology wise. Okay, fault have displacement. Okay. So, and this is very critical to like evaluate this such kind of usually carbonate rocks. Open hole will show you the static condition, but when you come to the production, you will see a different picture. Maybe you need to revisit your petrotype evaluation or subdivision of your formation. Okay, based on reproduction. This is really important. That's happening in many fields. You produce, you perforate everything, and there is water in the middle. And by the way, this is a very hard issue to fix. Maybe you're injecting gas also. You have something in the middle. Okay, it's called encroachment, breakthrough. It's come in the middle of the perf. This is not easy to solve. Okay, you need to see where is this water come from nearby well. Okay, this can be figured easily by PLT logs. Okay, so. Conventional PLT tool, the string that we saw in the beginning, it's belong to conventional PLT tool. When you select this string that we saw, is like you're going to a shopping mall. Okay, like you're going to shopping mall. Oh, I need a PLT that size, spinner that size. I need density that type. I need CCL that type. Okay, even there is usual string, but sometimes you have a special a special requirement for your roll bore. So is it memory or it's telemetry? Okay, but you need for calibration only gamma ray or it's gamma ray CCL, fluid acidification. But you will go with acoustic density, radioactive density. You will need to connect capacitance as well if you have three-phase flow. You have you. Okay, they put quartz pressure. I put quartz pressure here because you can get the what you call the density derivatives from pressure reading. Accessory for nickel joint if you have some kind of deviation, okay, or not very smooth trajectory. Flow meter, you use line spinners, full bore spinner. Sometimes you use only line spinner. If you connect some battery below and spectral noise or something, okay, or something else, your depend on your application for full bore. What size of full bore? Okay, and we see this one. It can be collapsed. So, continuous spinner in injector wells, or sometimes you have very restricted producer wear or gravel pack or something like that. So you cannot use the full bore spinner. You go for continuous spinner. Calipers, which is really good to see any change in wall bore. It's not like multi-finger caliper, but at least it will give you the caliper in the wall bore. And it's very critical when you don't have uh, like very smooth well bore, or you have some kind of you want to evaluate PLT inside too much ID variation, like you evaluate inside the tubing or too much completion element, this one will be really, really critical. Many benefits, for example, like even to confirm here for something. Okay, line synthesizers. Okay, so there is a few concepts we would like to talk about them quickly. You will hear a lot like about when you go for any specification sheet that for a tool that have a reading, you hear the word precision, accuracy, resolution. Also, there is extra nomenclature the next place. So what is it? What is these things that you will see in the specification sheet of any tool? So resolution is the any smallest increment the tool that can read. So for example, temperature log can read till 0.1 change. This is the small increment. Who's Dr. Mohammed? Dr. Mohammed?
Yes, Mr.
There
Mazin.
is there is some people is making a notation. Can you?
Annotation.
Yes, it's crashed. It's happened many times. Okay, can you stop them? Clear our drawing. So I clear the drawing, but they keep.
I cleared them, but I don't know.
You
They
can't stop from host tool. Host, you can't prevent from drawing.
all of them
Activate it, huh?
stopped to do
Mm.
anything, but I don't know.
Okay,
Okay,
okay, no problem. So we'll ask kindly the attendees not to make any scratches on the, because this one will be recorded and will put on YouTube. So we prefer there will be no scratch or annotation on this one.
okay,
Thank you. So precision is repeatability of the tool reading. You keep repeating the tool reading if you go to the same spot or same event. Accuracy is how much the tool is deviated from a standard reading. Like you have temperature measurement, which you are sure 100% this one is the one is reading correctly, and you manufacture a tool that read a temperature, let's say by different physics, how much the difference between this one and the standard reading. It have to be very little. Okay, so usually you'll find accuracy and resolution in the spec sheet for most tool. Precision you will not see. Maybe it's something in a manufacturing plant. Okay, so let's see. This one have high precision. It's reading the same, but it's very far from the standard reading. This one have a somewhat accuracy. Okay, it's near from the center, but it is not on the same spot. So it's do not have precision. It's not coming to the same spot, but is near to the center. So it's have some accuracy but precision. This one no precision, no accuracy, and this one have both. It's precise and accurate. So another terms that we use in wireline domain. Okay, calibration, normalization, verification. Calibration is transforming one variable to create another variable criteria. Like you have a spinner reading, transform it to a velocity. You have a capacitance, you transform it to hold up percent. It's like changing one physical terms to another physical terms using a calibration. It can be a cross plot or empirical equation or something like that. Maybe AI nowadays, like a black box. Normalization. Okay, it is just changing a scale, but the physical not called item, the physical variable, okay, will stay in the same criteria. So like you have a gamma ray and you change between case hole and open hole and you normalize the case hole to open hole, it is still in the gamma ray unit, nothing changed. The other two examples is from advanced course, okay, I delivered before. So it's related to a cap and N cap, okay, it's related to, actually it is a multi-array tool. This one also. Verification is just check this tool is working or not. Like you bring the density tool and you put it in water, it's read 1. You put it in air, it's reading 0.03. That's all. Verification is just checking the tool. Verified the tool is function. Okay? We don't play with any physical term or anything. Okay. So let's go quickly through the conventional tools. Okay, usually we have a gamma ray tool. This is a passive tool, which is mean it's only receive the data. All the tool we'll see in here is a passive tool that they don't emit anything, only the radioactive density tool. And by the way, before we start here, please forget anything about OpenHole. Usually when I deliver this webinar or the full course, people start to ask me about density log, neutron log, resistivity log, all these things. No, we are totally in different domain. We are talking about production logging tool in a cased hole well. We can run it in open hole well to evaluate also downhole performance. Okay, but we are talking about different domain. Just forget about open hole domain. So uh, gamma ray, it is CCL. This tool, I will not go to the physics of tool. We don't have time. Okay, this will require a special course. Okay, I will just talk about the benefit. This tool is used usually for correlation. Both of them is passive tool. That mean they receive some kind of signal, but they don't emit anything. It's mostly a correlation tool. So it's not like open hole use gamma ray to calculate V shell or these things. No, this is a different story. Okay, acoustic density tool. It's have some kind of tuning fork here, and this one have effect by resistance of type of fluid. There's a black box, and it's changing to a density reading. This one usually do not have what's called a Shop calibration. Okay, because you will receive this one in count per second as we talk, and we change it to a density unit. Okay, this one is done each few years. It do not need a pre-job calibration. Sorry, it's need a shop calibration. That means our master calibration that we do each few years. Okay, depend on manufacturer, but it do not need a pre-job calibration like a radioactive density. This one will give us a density tool. Usually when we have two-phase liquid gas, it's have been erratic reading. It's affected by flow regime. And when we have densities in the wellbore more than 1.25, it's maybe all readings and unreliable. This is the only tool, okay, the only tool that is active tool. Okay, not a passive tool. It's emit something. There is something in the middle. Take this emission, okay, and it's received some kind of signal. It transforms this signal to a density reading. This one is required a pre-job. Before each job of PLT, you need to calibrate this one. Before each job, master calibration each view is not worth it. Okay, answers have to be stated in the log. And there is a detailed document how you make preferred 5 points, like 2 different water, 2 different oil, 1 point in the air, because the slope of each calibration type of fluid is different. Okay, I will not go deep with this one due to time limitation. In all cases, it will give you a density reading. A fluid capacitance. This is also a fluid identification tool. Okay, it depends on dielectric properties. It's very good. It's very useful if you have a 3-phase, because the program, okay, will need at least two fluid identification tool to analyze if you have 3-phase. Also, if the density of oil and water has become so near, okay, this one will be very good to confirm the water percent. Usually it will be conductive phase after water exceed 40%. Okay, this is the fluid capacitance. Quartz pressure and temperature. Okay, this is the temperature, and there is small button for pressure somewhere. Okay, it's direct reading. It will give you the temperature of the wellbore, but the temperature is mostly the only tool that can see behind the casing. It can see what is happening behind the casing for a few feet. Okay, all the other tools read just inside what's happening inside the wellbore. And you will see some kind of example of temperature. This is the most important piece of production logging tool. It is the spinner, which is rotate, and we need to calibrate also, transform this rotation per second, transform it to what we call the spinner calibration, as we discussed previously. This term calibration, changing one physical variable to another physical variable. And we'll talk a little bit in detail about how we change this one. And this one will show us what is the rate downhole. This is the backup one. It is the align spinner. It It also measure the flow rate, something rotate inside it. Okay, it's more rigid design. So if the other one is failed, we usually use this one as a backup, or sometimes we use it if we have some kind of special cases when we cannot run the full bore spinner. This is turbine spinner. Okay, so, there is a better type that have open shreds here. Okay, this one uses usually injector, because what's happened for this one, it can be when the injection come from above, these blades can be collapsed, it's closed. Okay, this one it just have, it's exactly the same of this one, have a rotating spinner, nothing, no blades collapse inside this one, and it's very useful when you have a injector well with very high injection. Okay, sometimes we use it in a producer when you have, as I mentioned, gravel pack or some kind of restriction. We use this type also. We don't prefer it because the torque that need to rotate the spinner, the blade inside is much higher than the full bore spinner, so we don't see the tiny rates sometimes. Okay, this is the XY caliper that we talk about it until it's have only 4 arms. I believe there is 6 arm type. I'm not sure. The 4 arm types, and it measures the ID of the wellboards. It's very good to detect if the perf on depth, if we have any variation inside the ID. Its reading can be used directly in the interpretation software. Okay, typical PLT string. This is the how usually you will see it in the log. Okay, you will have the full bore spinner, inline spinner, XY caliper. This is the density tool, pressure capacitance. This is the centralizer, gamma CCL, master controller, and so on. Okay, sinker bar. Okay, so this is the usual conventional PLT string. So let's talk how we operate PLT. So this is a well bore. This is a perforation in the well bore. And this is the end of tubing. So there is a term in the PLT domain. It's called PLT pass. Okay. So what is a PLT pass? Um, we refer to a PLT pass is the data set that we acquire during a down run or up run with an PLT string. Okay. In the 1982, there is a guy called Pibler. I believe it's work for Schlimberger. He presents a method called multi-passes interpretation method. If you go to, like during our college study, they give us some kind of document belong to the 70s, and you can see there is only one PLT run. That's all. Okay, but they changed this one. This one come up to with a calibration method to transform PLT data, PLT data uh, using 3 and more passes, okay, with a plot called calibration plot, transform RPS to a velocity, okay. And now this his method is have been standardized worldwide with all PLT operation, and because of that, you will see all the conventional PLTs, conventional, not multi-array. Multi-array will not need too much logging, okay. It's because it's different theory. So you will see this all the surface company operator, they will ask for 3 passes or 4, so they can make a very nice calibration plot. I will not talk about this one. It is not, there is no time to talk about calibration details, but I'll tell you the reason. So usually, so let's see what is pass. We run PLT, okay. Okay, we stop here for stabilization level, because if you are injecting or producing, you need to wait for the well to stabilize. Some operator, they just said, oh, just wait for 1 hour. Some operator is so tight. They wait there till you have a pressure of 1 to 2 psi per 2 hour. Then you will start passes. And the reason for that, if the pressure is vary too much during PLT pass, the data will be overlap of each other. Oh, it's not animated. Let's see why it is not animated. Let's hope it's animated. Unfortunately, there's something goes wrong with the animation. Okay, so what's happened? This is the PLT. It's go down to well bore. Okay, it's supposed to animate, but for some reason, okay. So this PLT go down and go up. Each go down and up is called pass, and we change the speed. Okay, I believe because of Zoom. Usually I test it many times, it's work. Okay, so we create several passes. We go down with speed of 10, we go up with speed of 10, we go down with speed of 20 meter per minute, we go up with 20 meter per minute. Then we repeat that for 30 and 30. We have 6 data sets. So whatever the convey system we use silk line, wire line, cold tubing, whatever, we will have the same data set. The data set for PLT passes is not complicated. We can get them in blast format. They are like ASCII file. We don't need some kind of complicated binary 2D file, okay, that we see usually for something like image log of your VDL or some kind of acoustic image. So you can get the data LAS format. What this LAS format have? We see like we get 6 files. Each file you will have like line speed, flow meter, and the change of all these files is just the line speed. So we'll see the line speed, flow meter, pressure, temperature, line flow, gamma ray, CCL, and tension. And this is the spinner. Okay. So usually you will have these curves, okay, with these passes. You load them in interpretation software, and you will have some kind of plot. Except this one, it is interpretation wise. All the other is directly from reading. And this is a good example of producer well. So the red one is perforation. This is the line speed. There is 8 passes with 4 different speed up and down. This is the spinner, you see. It is 0 here, then some kind of production here, some kind of production here, and there's some jetting effect, look like. Production here, and you go there, you don't see too much production, but maybe from this zone. Okay, what is this? It is a temperature derivatives. It's very easy to confirm the production, especially it is when it's below the spinner threshold, when the zone that spinner cannot see the production. For example, I see this one. So what's temperature C? Some production, temperature derivatives. Some production here, this one. It's nothing here. This is part of perf idle. Nothing is not working. You see some production here and some production here. And this is, some people like to see the full temperature. This is the full temperature. Okay. It's not as clear as the temperature derivatives. Okay. Density log. You can see there is a drop in density. So this confirms this one. There is some kind of start of light entry here. And you see some drop, some drop here. There's some increase here. Interesting. Maybe type of fluid. Okay. This is also interpretation curve. This is like pressure derivatives for temperature. You can see it's very similar to this one. Some people use it as a QC curve for temperature reading. Okay, after you make some correction for deviation, but not really, because there's too many factors. Okay, that need to be. Because of that, we use a dedicated density tool. We don't take the pressure derivatives. Okay, this is the capacitance, as you see. Okay, it is increasing. And this is the gamma ray. Okay, CCR. Okay, and this is the pressure, this is the temperature, and this is the line tension. This is the usual plot of a raw data or of a producer well. Okay, and this is the data will be entered in software and will be get interpreted. Okay. I don't believe I put anything about interpretation example here, because this is it is not interpretation, it's overview of the PLT tool itself mostly, okay, and general about the data. Sometimes you heard the terms multi-rate, okay, we do some kind of multi-rate to make IPR plot or to study selective flow performance for each well, okay, and you make 3 or 2 choke or 4 chokes, okay, and you're increasing the choke, there's drop pressure, and you shut down. And the gap here, it is the time where we make the PLT recording, when we change it from time-based to the depth-based, okay, to make the recording. Okay, this is example of injector well, and I can see this is a very good example to show some kind of fracture behavior or injection-induced fracture. This may be a natural fracture. Some kind of injector, they create artificial fracture. And you can sometimes see that even in all tests of a quarter unit slope for the people that have experience in well testing. So you go there, boom, everything go from the injecting this one. Let's see how it's changed. For a producer, it's increasing from 0, it's increasing to positive. For injector, it's come from negative and go to 0. Okay, just to differentiate for the people that do not have much experience in PLT. Okay, and you see the temperature is not, we don't take temperature derivatives, okay, because you read the temperature of injection itself. It start to heating up here, okay, start to heating up here. Try to back to the formation temperature. That means mostly the injections start to stop here, and you see even the spinner start to be so smooth in this area. Okay, so this is the temperature. Mostly injection stopped here. Most injection go to this interval. There is some kind of, I can say there's here. There's some kind of injection go to this zone also after it stopped. This zone is dead. Maybe need some kind of dyes or something. Okay, capacitance, it is just one type of fluid. There's some change here in the sump. Similar here for density. You are reading water density, so it's about 1. Brine, like, sorry, injection water, not brine, injection water density. Okay, and this is the usual tool. And this is a deviated way, by the way, about 33 or 34 deviated way. Okay, we can do also multi-rate test, and if you want to see injectivity index or something like that for production engineer, okay, or reservoir engineer, okay, similar, okay, injection 1, injection, you increase injection, boom, you close, you do something like a build-up, but for injector well, they called it PFO, pressure fall off. So for producer, we called it PPU. For injector, we called it PFO. You take this data, you put it in Sapphire, you interpret it, and you make a pressure transient analysis. Okay. So what you get after, let's assume you are using Emirate software. There is too many other software, okay, but Emirate is most famous software, okay, but there's too many software, okay. You can use this one, even the famous software like for OpenHole, like Geolog or Tectopetrophysics or Techlog. Right now they do same interpretation. It's not only Emirate. So what you will get if you analyze by Emirate, you will get a last file that have the rates, okay, velocity and final temperature, final pressure that have been used, and you will get an interactively used Emirate file that if you send it to somebody, but have to have same Emirate, also have a function Emirate to open it and can see what is inside this file. So usually this is the delivery for what we called it the client CD, okay, that's received by client or sent by service provider. It will have the Emirate file. This is the old version KE2 and not KE5. There is the Emirate output. There is the final report. There is a last file that contain final output. You can load it in any software if you make any drawing or time-lapse plot. You make a summary, usually like executive summary. So this is okay, it's rates, there's water rate, there's final density have been used, and apparent velocity. Okay. So we saw there is too many PLT data. There is a spinner, there is density, there is capacitance, there is XY caliper. So why we don't run a spinner on that? So, okay. So let's see. So usually there is no direct measurement for the flow inside it. So what we do, we find a stabilized area. Okay, let's assume this is stabilized. There is no flow on this or intake in this area. and there is nothing in this area. This is when you use the software, you will understand this better. And there is no flow in this area or intake. So the difference rate will represent this flow rate. The difference rate here will represent this flow rate. This is the basic principle of PLT interpretation. Okay, but do you have always a single phase flow? Do you have always a smooth ID? Okay, now we go to the next step. We need to know the rate. Okay, this is the main goal. So what we need, if we're using a single, we have a single phase well bore. We just need the velocity and the area. The area, okay, either we take it from caliper, which is highly recommended, or you take it طبعا from slowest up caliper log, or you take it from ID of the casing if you don't have too much change, or the ID of the pipe that you evaluate. Okay, let's assume it's casing. Okay, velocity you will get it from spinner calibration. What if you have multi rate flow? Okay, I'll not talk too much about hold up, all these things. This is we'll need a full course. You will need velocity, area, and the hold up, just like a moving area. Okay, so of each fluid of the each phase in the well bore. The area, okay, the area also you get it from caliper or the pipe ID. Velocity is from spinner calibration. The hold up here, the trick, you will need this density tool, capacitance tool, okay, and we deal with hold up. We don't use we deal with densities or capacitance reading, optical reading. So that's mean we can bring this hold up from different sources. Okay, so velocity, we can use spinner. There's advanced tool like nuclear method, oxygen activation, soluble tracers, temperature measurement like it's like temperature simulation. Okay, fluid composition. Okay, so because we're looking for hold up, so it can be bring from density, from nuclear density, from this is density measurement. It can be acoustic or radioactive density or radio manometer. We can bring the hold up from capacitance. We can bring it from optical measurement, refractive index. Okay, from pulse neutron. I'm not sure about resistivity measurement is like what you call this rat. Okay, like a rat tool. Okay, we'll see it in the multi-array tool in a while. Okay, flow area either from caliper or casing ID, and because of that, we need to use a PLT strings. Not a single tool will be enough. We need to integrate to have the full answer. What is happening down the well bore? Okay, so if you deal with a deviated well, okay, you will have some kind of such problem. Okay, let's hope this video work.
Do you need to stop the recording or not?
No, this video is okay. Is
Okay,
not do
okay.
not have any confidential. There is another video we need to stop. Okay, thank you. Okay, so this one is called flow loop. This one is called flow loop. Okay, flow loop is like some kind of device. They put the spinner inside it and they make experiment in it. You know what they did here? They put it in a 40-degree flow loop. They put a spinner. This is the spinner lying here, and they put some kind of coloring. Okay, to represent oil production, and there is some kind of static water here. Okay, so they inject actually where they inject the oil is this coloring is not clear from this video. It's somewhere here. So they inject this coloring. It's go to upward. It's lighter than the water. You can see what's happening here. Spinner is sleeping or laying down on the downside of the wellbore. This is the blade of spinner. It is inside the water area. If we have density, capacitance, everything here behind it, also it is in the water area. What is happening above? All the oil is moving in a very high speed in the low side of the wellbore. What is creating? Okay, it will rotate the spinner, but because it's going in very high speed, it will rotate the spinner in the reverse way. So let's see. You see, this one is going very up and create turbulences, reverse turbulences. So it will create a fake downward cross flow. How this one will look like? Okay. So before we go to the how it look like, so we need to have three conditions to have apparent downhole flow. We have a lot. This is a very common phenomenon. It's not like something you see one time per life. If you work in a field that have deviated well, you will see that every day. Every day, in every run, you will go with and producer well, and so you need to understand this one. Go with PLT run. So you need to have your well deviation. You have to have two-phase flow. If you have just injector well or a single phase producer, something like that, there is no water or something, you will not see. So to form this phenomena, there have to be deviation. There is two-phase downhole there in the area that log have been surveyed, and the production of the light phase, which is oil, for example, it is a very low rate. It will be low rate, but it will be at very high speed because it will take small area in the pipe. Let's see how this one look like. So similar to photo I show you, you see spinner sleeping here in the low side, oil flow go. You see speed of oil flow is very high. Water, because of turbulence, is low speed, but it's rotate the spinner in minus because spinner do not see the oil. Oil is in the upside. You see, and this one is rotate in minus. So oil go there. This one is like a more cartoon drawing. You see, you produce oil here. Okay, and it's make turbulence. As this turbulence you go is downward and create the spinner reading in minus. Let's see how it looks like in real life. This is a cross flow well. You see, it's based on temperature. Okay, even this, start producing oil from here. How we know it's oil? We can see from this is density tool. We can see there is drop in density here. If I maximize this one, you see also from capacitance a little bit there is a change here. So we have evidence. This is a light production, but what's happened? It's going minus. So if somebody with no experience with this phenomena, oh, will come, oh, there's a cross flow coming from here going down. No, it's not a cross flow. This is oil production and it's making this turbulence. Okay, and you need to register it in the interpretation as producer zone. It's not a dead zone. Okay, so this is a usual case. It's called apparent downhole flow. Okay, for people that work in fields with many deviated well, will see this case a lot. Okay, so what's cross flow? You have two zones or more that have different pressure. One have high pressure, one have low pressure, and you shut in the well. What's happened? The one with high pressure will go producing to the low pressure zone, and this one called thief zone. Okay, so sometimes you have upward cross flow from down to up. You see the spinner go to the right side. Okay, or you see like apparent downhole flow, but this is a real one where you produce from here to here, and you can see very distinctive temperature signature. Sometimes you cannot know from temperature all it's up or down. Okay, you see it's very similar temperature. But for spinner, it's for sure it will detect where is the direction of cross flow. You see this one is downward. It's come from up. This is a real downward cross flow, not a fake one like we see in the producer well. Okay. Let's see. Oh, okay. So let's go quickly with horizontal well. In very simple term, there is nothing called horizontal well. Horizontal is everything but not horizontal. Usually this is our dream horizontal. Usually this is our real horizontal trajectory. Okay. So when have such case of horizontal. Oh, this one is called heel. This one called the two. And there is different type of completion for this one. You can keep it open hole, you can put a slotted liner, you can perforate it, you can put external packers, okay, slot liner, multilaterals. You can play around with different things. So what's happened in this such case? Okay, we know this right now. It is not very smooth as we expect. So there's up and downs, up and downs. So what's happened? Let's assume we're producing and there is no change in the flow rate. And many people ask me how it's come there is no change in flow rate. Flow rate is fixed because there is change in area per each fluid and the velocity of each fluid. The velocity of each fluid is changing, and the area that occupied by each fluid area, which is hauled up, the area is a moving area, okay, is changing. But the rate stay the same because the rate is velocity multiplied by area. So area change, velocity change, flow rate is still constant. You see? Okay. So you see here, rate is constant. Hold up is changing. Okay. So what's happened? We have we are producing. I will show you better animation than this one. We're producing from this side to this side. Okay. It start climbing up, climbing up. So light phase become very fast. Heavy phase becomes slow but take most area. They reach to 90 degree, like a typical horizontal. They both like equal to each other. They start to go down. Light phase take most of the area. Heavy phase take small area, but become very fast because of gravity. Okay, all of them because of gravity effect. This one become very slow. Okay, so you will see a very changeable, when you start to analyze. Okay, so let's back to this drawing again. 88 degree, 90 degree, 22 degree flow direction here, and we have production increasing with this direction. Okay, so what's happening here? This is speed. You see light phase very fast. Okay, slow. Heavy phase very slow. 90 degree, both of them equal speed mostly. Draw go down in angle, 92 angle, like going down. Okay, you see light phase very slow, heavy phase very fast, but it's taking a small area. Okay, and this is this is when it's become deviated and we see a recirculation, the one we saw. Okay, this is the increase of protection. So what is changing here? Actually, it's just, you see this one drawing in the below, you see like when you draw it in the software, you see too much, a little oil, too much oil, little oil, too much oil. But actually, it's not like this. It's just changing in the hold up. Okay, but at the end, you will see the production as it is, the final production. Okay. I try to make this slide, okay, is very interactive slide. So I will show you some lab experiment for this one. Let's see this one. So 88 degree, you see this lab experience, very interesting. Boom, light phase up. 90 degree, you see equal color. Boom, down. Let's see, this one have to be very fast. Boom, you see, very fast. Recirculation. Light phase go up, heavy phase go down. Recirculation. Okay, so I created this slide because many people couldn't understand how this, is this real life or just we are putting nice color, nice plot. Actually, this have been proven by lab, and because of that, these multi-array tool have been developed. So also flow regime. You have vertical wall, you have bubble flow, slug flow, channel flow, annular flow, many other flow. When you have horizontal well, which is never be horizontal, you will have a different type of mostly stratified flow, okay, wavy annular, disparate bubble flow. So we'll have a different kind of flow, but mostly for sure you will have the heavy phase laying down and light phase above. Okay, so let's go quickly. We see why this horizontal well is complicating everything up. Also deviated well, complicating everything up. We have this apparent downhole flow. We have all this up and downs in horizontal well. So we need to go for more advanced tool. So in very simple term, we need to put a tool that cover the full well bore. So it can see what's happening the downside, middle side, and on middle area of the well bore and the high area of the well bore. You can find market some tool that can be provided by any wireline service provider, and you can find some kind of tool is a single source by the manufacturer of this tool only. Like Schlumberger, they have their own tool called FSI. It's a famous tool since many years. Sondex have maps and they add the GUT to it, the optical tool, Okay, it's very long tool, and this can be provided by anyone. They sell it to everybody or rent it to everybody. This one is run by Schlumberger only. You will have a flow array sensing tool. It's manufactured by a French company called OpenField. Also, it can be provided to many wireline service provider um, because it's manufactured tool. It's the wireline company. Um, uh, Baker Hughes have their own also a very good multi-array tool. It's called Pi. Okay, they don't give it to anybody. They just run it by themselves. By the way, Sondex belong to Baker. So what they do, they have some tools sell to everybody. They have some tool they don't sell to anybody. They just run it by themselves. So who's have the optical tool in the market that can be used to also as to detect hold up? Okay, Baker Hughes have it in the Pi and in the GAT, which is can taken by connect to the maps or any conventional PLT from Sondex. Okay. Schlumberger have FSI and Ghost. Open field have fast. Okay. So right now the number of optical tool in the field have been increased. Okay. As per my knowledge, before it was all Schlumberger. Now the competition have been increased. So Schlumberger tools have four spinner, have also one mini spinner on the bottom, or one optical, one electrical probe, five optical, electrical. Okay, this is the small tiny spinner. This is the other probes. Okay. This is fast tool. Okay, it's have four arms. You can connect two tool with 45-degree difference, so you can have better coverage to the wellbore. It's very short tool. It's been run in many fields in Middle East and Europe and other fields. You can put many props here. It's have some kind of acoustic tool here. Okay, it's very nice tool as well. This is Baker Hughes tool Pi. It's very strong. It's very strong tool. It's have six arm and you can put three sensor, three small sensor on each arm. His coverage is very good to the wall bore. Length is 2 meter only. Okay. And the maps, it is a very long tool. It's also a good tool used by many operator and field service company. This is the tiny spinner. This is the resistance tool, and this is the capacitance. So this is a little bit advanced capacitance. Have 12 capacitance, 12 resistance, and four spinners. Dr. Mohammed,
Yes, Mr. Mazin.
can you hold please the recording, because I will show some kind of confidential video.
Sure.
Okay. So I believe we are reaching to the end of our lecture. We pass our time by 10 or 15 minutes. I hope I wasn't boring for the attendees. Okay.
Please
Uh,
continue, Mr. Mazin.
okay.
It's
Thank you.
interesting to hear you and
Thank you.
see
Thank
new
you.
information. Thank you.
Thank you. Thank you, Doctor. It's my pleasure. Practical PLT principles. I say Emirate software profession. Actually, it's I put Emirate because it's widely used. Okay, but I'm not recommending any software here. Okay, I'm neutral with all the software that people can use. Okay, so uh, so one of the recommended video learning video for PLT's principles, all these tools that we talk about, all this advanced thing, all the basics of hold up, the tool equation, and you can find more information, more videos that I couldn't show. You can go to Society of Petrophysics and will log in Iraq branch on YouTube. You can search only SPWLI Iraq, and you go to our playlist for 2024. We make 10 webinars this year. This is a very rich videos. If you want to go to the arena of PLT analysis domain, I will highly recommend to go to this focus playlist. Okay, I don't believe in the YouTube you'll find any such focus playlist of from all this software provider and tool manufacturers talk only about PLT. Also, you will find 2023 playlist if you're interested in full case hole domain, it talk about cement logs and integrity corrosion from also and tool manufacturer. Okay. Um, you can visit Kappa Engineering on LinkedIn, Kappa on YouTube, Kappa if you're interested to see how you can use Emirate to make interpretation. Also, they make continuous webinar to use their software. Other software provider also do the same. Okay. Um, this is a very nice books. Okay, for case hole domain, this have all the PLT, all the cement, all the integrity, MFC, electromagnetic tool. You'll find everything here. I put this book also because it will talk about, in general, about dynamic data analysis, like merely well test analysis and the other software that related to petroleum engineering, mostly domain. But this one, the case hole logging, is a very new book, and you can download it for free from Kappa website. Okay. This is a great book. I already printed a hard copy for me. I mostly read it all. It's very one of the best references. It's 2013 or 15, but still a very valid book. This is an old book. There is a new version for this one. It's been updated last year or I believe this year or last year. Um, it's not publicly available. You need to purchase it, but the old version is available. And this one have all the real basic of PLT interpretation that have been transformed to a software language right now. So another source, if you're using Emerald or any other software, you just go to the help and you look for the production log interpretation. You will have a very, very rich and wealth of information in these softwares, Emerald or any other. I believe that's all from my side. I hope the webinar was beneficial. Uh, and thank you all. We can go for Q&A session right now.
Thank you, Mr. Mazin. Really, the webinar was very informative. So please let's head over to the chat box to review the questions and answer them.
Okay, I bring it to the share screen. I didn't see too much question. Objective of capacitance, Muhammad Zuhair, Mr. Muhammad Zuhair. Objective of capacitance, usually if you have three-phase flow or you have some kind of density of water in heavy oils, where you cannot really distinguish water from oils, it will be useful. So you have two cases, use it. Okay, because the software, if you have three-phase, okay, it's need two fluid identifiers. So capacitance will be very useful on this one. What's up, Mr. Mazin? You can, Hama Salim, you can contact me on LinkedIn. Okay, just write Mazin Al-Hilali and you will find and you can send me a message. Otherwise, you can just write email to support@Enkidu and I can communicate with them. This is done by usually by field engineer, and they have some kind of what's so-called SOP, standard operation practices, per each tool. So it isn't like one tool you test. There's many procedure. Okay, some procedure related to its tools itself, some procedure related to its tool that's connected to one line trucks. Okay, so each tool it's have its own SOP to be do before logging operation. FDR, it's fluid density radioactive. Okay, it is also a density tool. There is no difference. This uses a radioactive physics principle. That's all. It is a density tool. And there is another type called gradiometer, which also gives density. And there is another type based on acoustic tuning forks called give you density tool. This does not cover the production log interpretation. Or you can go to SPWLA website and you can watch many videos talking about interpretation from different software company. Or Abdel Aziz Khalifa, yes. We are in injector wells, we are using both full bore spinner and inline spinner. Okay, both is good. Okay, but sometimes you have a very high injection above 25,000. Okay, there is such kind of injection. Okay, it is not recommended to use full bore spinner because sometimes it can be closed. Other term, collapse, the plate will be closed. So it's better to use in very high rate you can use the align spinner. Not align in the middle, the turbine spinner, okay, or the continuous spinner instead of full bore. The align will be there in all cases. David Martinez, how can we know the total volume of fluid production discriminated area of influence when potential water from the productive area of fluid associated with the black oil, volatile oil? I'm not sure about your answer, like a question, okay, because to enter some kind of arena related to like type of oil or reservoir oil. But in general, if you want to discriminate, you have this fluid identification tool, which is density or density tool. Okay, sometimes the software give you the privilege to make subzone per each oil type, because sometimes you perforate from different formation and you make some kind of what's so-called commingle production. So you have the PVT of each formation, and you go to the software and you explain to him. There is a tick. Tell him from this interval to this interval use this PVT. From this interval to this interval use this kind of PVT. Okay. For the people that send thanks message, I like to thank them all to attend this webinar. Some question I couldn't really understand, but they can send, if they have more detail, they can send it later by email.
Mr. Mazin, there is a question at the end of the chat box. You can
Yes,
read it, please.
yes. Can PLT detect water and gas coning? In theory, you will see the entrance. If it's from the top of the perf, of the bottom of the perf, it will refer to coning, usually. I believe so. But if it's in the middle, which will refer to encroachment or breakthrough. Artificial intelligence. I didn't see any real application for any artificial intelligence in the PLT interpretation nowadays. We deal with PLT all the time, and no real application on daily basis. If you want to publish a paper, yeah, it will be nice, but the daily work, the software is provide you everything, and with the increasing of your experience, okay, you can do this interpretation really efficient and quick. Yes, the operator and even service provider, they have to train their staff on the tool and on the interpretation. And usually some operator ask for the CV from service provider to see their competency. Usually any operator required at least one senior petrophysicist, and it can be except one trainee or junior staff with him, but at least one domain. Do you open? I didn't understand. Do you do all the open? No, it's الشات. Do the open all multi-rate. Record on station. It's continuous reading. I'm not sure. I'll shut asking about station. You can take station for different purpose, but it's a continuous reading. There is no difference. Should the duration of each flow regime during multi-rate be equal There's some variation. Okay, for multi-rate flow, okay, there is different factor here, but the main factor, you you need to have a stabilized pressure during the duration of this multi-rate. Like when you have a stabilized pressure of 1 to 2 psi, sometimes stabilize in 10 hours, you can start your PLT logging. Okay, sometimes stabilize in 2 days. Okay, so it depends how much time it take to stabilization. This is usual practices for operator, because what you will do with multi-rate, you change the choke, you play with all the flow regime, and the well not stabilize, and you start your PLT. What the benefit of this multi-rate? You need to wait, stabilize for sufficient time, a 1 day or something like that. Then you will do your PLT passes. Okay. Send me the attendance form. Yes, Dr. Mohammed, I believe we can close the presentation right now. If anybody have any more question, he can drop email to support.
Okay, Mr. Mazen. We can close our webinar, but before that, at the conclusion of today's webinar on evaluating downhole performance using production logging tools PLT, dear attendees, thank you for joining today's the last webinar in 2024 for Enkidu, and you're joining in 2024 Enkidu training sessions. We hope you found the content informative and valuable. We look forward to welcoming you to our future events in 2025. Mr. Mazen, the Enkidu training team appreciates your efforts and the informative presentation you delivered. Wishing you a wonderful day, a happy new year, and goodbye.
Thank you, Doctor. A happy new year for all, and I wish all the best for Aikido training. My pleasure. Bye bye.
Bye.